Hello everyone! We are here to introduce our latest work on split learning privacy leaks, named a Stealthy Wrongdoer, feature-oriented reconstruction attack against split learning. Split learning is an emerging distributed learning paradigm for resource-limited scenarios, which can split the neural network model into both client-side and server-side. It's generally believed that split learning provides a secure and efficient training protocol by allowing the client to retain a portion of the model and training data locally, while offloading most of the computing overhead to the server. However, recent studies have highlighted that the server can utilize the smashed data output by the client to reconstruct the training data. We discover a fundamental phenomenon that the client model has its own representation preference, which can be reflected through the smashed data. This phenomenon indicates that a server adversary could establish a substitute client by narrowing the reference distance with the real client to conduct a reconstruction attack. With a well-trained substitute client, the server can successfully recover the private data by constructing an inverse network. Inspired by the differences in model representation preferences, we propose a novel data reconstruction attack against split learning. To efficiently measure the preference distance of different representations, we introduce domain discriminator network and MKMMD. These techniques are widely used in domain adaptation, enabling us to project various representation preferences into a shared space for comparison. Fora consists of three phases: substitute model construction, attack model training, and private data reconstruction. Compared to malicious attackers, Fora exhibit almost identical attack effectiveness, and when faced with detection methods from the client, Fora is completely unaffected, while the image quality of FSHA significantly decreases. Compared to other semi-honest attacks, the images reconstructed by Fora exhibit a significant improvement visually. We also measure the feature distance between the proxy clients built by UN Split, PCAT, and Fora and the target client. The results show that the substitute clients trained by our method exhibit more similar representation preferences to the target client. We also analyze the effect of several important factors regarding the auxiliary dataset on attack performance. We first explore the impact of the fitting level of substitute models by varying the size of the auxiliary data. Then, we discuss the impact of the presence of a more significant distribution shift, i.e., the absence of some categories between the auxiliary and target samples. The results showed that Fora demonstrated high robustness in the face of changes in the auxiliary dataset. After validating the impact of the auxiliary dataset, here we are interested in the impact of substitute client architectures on Fora. We choose three different model structures as attack variants: the VGG block, the ResNet block, and the DenseNet block. The SSIM and LPIPS quantizations results for the reconstructed image remain similar. This indicates that the extracted representation preferences on the basis of MKMDD and discriminator are close to that of the target client, despite the fact that the substitute client use different architectures. We select three well-known defense techniques: distance correlation minimization, differential privacy, and noise obfuscation, to evaluate the effectiveness of Fora. The experimental results show that the current defense effect has a very limited impact on fora, or sacrifice utility to achieve defense goals. We also discussed future improvements for fora, such as combining advanced generative model like StealthGAN. Therefore, the reconstruction task in fora can be further optimized using pre-trained StealthGAN with a well-trained substitute client. In summary, we propose a novel data reconstruction attack against split learning, named Feature-Oriented Reconstruction Attack. Unlike all previous attack schemes, Fora enables a semi-honest server to secretly reconstruct the client private training data with very little prior knowledge. Thanks to our new perspective of extracting representation preferences from smushed data, the server can contemporaneously train a substitute client that approximates the target client's behavior to conduct the attack. Our extensive experiments in various settings demonstrate the state-of-the-art performance of Fora. Due to its stealth and effectiveness, it poses a real privacy threat to split learning. We hope our work can inspire future efforts to exploit it in more practical split learning, and we are eager to draw attention to more robust defense techniques.